Okay, so what we're looking at is the frequency spectrum of our DAC using a non-oversampled output. So we're using just 8 points to create a sine wave. And our sine wave is basically sitting at 22.8 kilohertz. And these are our unwanted image frequencies. So this is what we're getting from non-oversampling, right? Basically, I have a filter set up, a cascaded filter set up, and I have it set at 1.7 megahertz. What I'm going to do is I'm going to decrease the filter to simulate, a reconstruction filter for our design. So let's say I move it to, let's say 60 kilohertz or around there. And we can see we have our main signal really didn't get affected much, but we also really dropped our image frequencies. Okay, so now we've uploaded our new code to the Arduino. So now we're doing oversampling. So we went from doing 8 points per sine wave cycle to 32, and we increased the sample rate to match that by 4. Notice we have the same frequency, right? So about 22.8 kilohertz. We still have our filter on at about 60 kilohertz. Notice we don't see any image frequencies. They're all dropped below negative 80 dBm. So we can already see that the same filter is working better on the oversample version of the code than the standard sample version, right? So that's the benefit of oversampling. Now let me go back to no filter, right? So you can see the image frequency. So now we're back to basically no filter, like we started on the previous example. And notice you can only see one image frequency. That's because we upped our sample rate by basically a factor of 4. So we're only seeing one image frequency, and we can see it's much farther away from the signal of interest.